This question was from section 1.7, number 18, I believe, and it's about finding the practical domain of a function. So we've got a situation here where our car is traveling on a highway. The distance in miles from its destination is given by d equals 483 minus 54t, and we're asked what the practical domain is. There's no other information that tells us anything about distance besides the equation. Looking for the practical domain, what possible t inputs can we have? I would suggest graphing this function. So I have the equation typed over here in Desmos. I just typed it in. And I can't really see very much going on. It looks like it's a vertical line. I know it's not, but I know that it has a very large y-intercept value, so vertical intercept value. So in this equation, the coefficient is my slope because it's the coefficient of the variable. So I see my slope as this part of the linear equation, and this is my y-intercept or vertical intercept. So I'm going to rescale this, because my upper height is going to be much larger than the default, which would happen to be around 7. So I'm going to pop it like to 500, say, so that I can get something bigger than the 483 there. Okay, so now I can see that I have this lovely diagonal line. I'll just zoom in a little bit out and move this. All right, so in this situation, our trip is beginning at time 0. So we're not really going to want to talk about values over here in this negative area. Our trip hasn't started until the initial time 0. And then you're going to be traveling past time 0. You're going to be traveling for a while until, you know what, you're going to get somewhere and you're going to stop. And you're not going to allow your distance to go negative. So you're going to stop when you've reached your destination, which is where you've reached a position of 0 where you're going to stop. So it looks like we're only going to be allowed to use inputs between 0 and 8.944. After 8.944, any additional input value would cause the output value to become negative, and that is not desirable in a distance situation like that. So that's where I get those two values. 0 as the first input. And so when I go and write the domain, I'm going to say 0 is the first input allowed, and then going up to the last input allowed at that 8.944, was it? To double check, I forgot the number. Yep, 8.944. All right, and so that is my practical domain for this situation. It's often, very often the case, linked to the x-intercept and y-intercept as the two boundary values, because in many cases, negative values are going to be the places where you stop making sense. Not in all cases. There are exceptions to this, of course, but that's the case in this one. And so that's 0 and 8.944. They rounded to 2 places, but there you go. We have our 2 border values for the practical domain. I hope that helps. If you have any more questions about it, let me know.